Hello, everybody, and welcome to our online meetup today. So it's really great to hear this sound again. So thanks for joining. And yeah, we have so many new information about MicroStream, and this is the reason why this online meetup is called the MicroStream, the upcoming fireworks. I guess we really have a firework, and it's great to have Christian here and Florian and Rudy, and we will go through all these new information about MicroStream. So here's an overview about the agenda. So we want to talk about a little bit about MicroStream and Eclipse, what's new in the upcoming version, MicroStream 8, MicroStream and other frameworks. We want to talk about MicroStream cluster in cloud. So today we are able to introduce MicroStream cloud and cluster as a beta version. And of course, we will have some time for Q&A. So if you have questions, yeah, you can interrupt us anytime and ask you a question, or yeah, you'll listen to the presentation, and perhaps this will already answer your questions. Or yeah, but please feel free and ask questions. So here are the people who write the code. So what we have done in the last weeks and months, so we enjoyed the beautiful weather. So yeah, this is from Lugano. So great photo from Lugano this year, and this is not from our holiday. It of course we work all the time on MicroStream. We were at Fox Days, so we did a lot of development, but we also are very active in the Java community at conferences, and we had a talk at great Fox Days Ticino in Lugano, Switzerland. And you had this, by the way, this is not my presentation. This is Patrick Baumgartner from the Java User Group Switzerland. Yeah, it was a great conference in January. And then some weeks ago, we were at JFocus in Sweden for the first time as with talks and as an exhibitor as well. And thank you everybody for joining my talk at JFocus. Was really exciting, and got really great feedback from the audience about what's new in the Java community, what's new in MicroStream. And we are on tour again this year. So there are so many upcoming conferences. April is gonna be crazy. So in April we will be exhibitor, and we'll have some talks at DevNexus in Atlanta. Then you can meet us at GeekCon in Krakow, Poland. And June, this will be a JCon month. So for the very first time, JCon Open Blend in Portorož, Slovenia. So if you have not plans for your holiday already, you should come to JCon Open Blend in Slovenia. Beautiful location, beautiful weather, and great Java topics. So everything together. And of course, you should not miss the JCon Europe in Cologne in June. This will be a really great conference back in the cinema, and there we have many MicroStream and related talks about MicroStream and what we are doing with MicroStream. Yeah, and we also be exhibitor at the VR Developers Congress, World Congress in Berlin. And of course, in November, our great JCon World Online Conference with many MicroStream talks. As I can see, some people are already joining. So now, MicroStream version 8. What's new? I like to talk a little bit about MicroStream version 8 with Florian. Hey, Florian.
Hey, how are you doing?
Yeah, great. So Florian and I, we had a meeting before this meetup, so it was really close but we were able to make it. Hey Florian, what's new in MicroStream version 8? So every single year we launch a new major release, which means you and your core team, you have a lot of time to implement new features. What's coming next?
So we already launched 2 release candidates, well, early access versions of the version 8, which will be finalized after the next new thing. I guess Markus will talk about it. And so the one of the big steps is we went to Java 11. MicroStream requires Java 11 from now. It's compiled to Java 11. Of course, it will run with higher versions like Java 17 and so on. But that's the big step, Java side. So we have a new Quarkus integration hosted at our repository. And the lazy collections is the other great features. So a lot of developers asked us, hey, how do I solve it? How do I make segments in my data? Should I create parts in my data model to only load customers beginning with letter A in a group and load them lazily and so on? Though it was doable before, but now we have a API for it, the lazy collections based on the Java util collections. We've got a list, a map, and a set, so the most used ones, of course. And internally, they use lazy loading with segmentation. So you don't have to worry about lazy loading anymore. You just define the segment size, and the collection itself will take care of the lazy loading part. So you can put millions and millions of records in one single collection without even thinking about running out of memory. So that's the big features. A lot of new stuff with our integrations, Spring Boot 1, Spring Boot 2 and 3, and we got some new type handlers for Java 17, mostly the immutable collections. Our serializer, the communication layer, now can be more customized with type information. It's a big improvement of our serializer API. So you can define how types are handled with the serializer, or if it's done by MicroStream itself. So Helidon got a great upgrade, and another thing was a migration tool. A lot of people asked us, and we launched it because MicroStream cannot be, the channel count in MicroStream cannot be changed easily if you got already an existing database or stored data. You cannot say, oh, I got a bigger machine, I double my channels and use my cores. That wasn't possible very easily, so you have to migrate your storage to be used with more channels, more hardware power, and therefore we got a migration tool which can be integrated easily because it's only a main you have to call with parameters. You can integrate it in your CI pipeline, and the storage will be migrated with a single call to this migration tool. So and a lot of fixes, of course. It's an exciting release. We will be happy to announce it finally in a few weeks, and you're free to go to try it out. The early access candidates are already online at Maven Central, so feel free and give us feedback if you like. Yeah.
Cool. Yeah, thank you, Florian. This sounds awesome. Especially the new collections are very interesting. I guess many developers are very interested in using these new collections. So because we had these questions all the time for many years, and now we can provide a solution, this makes us really happy. And thank you for the feedback. And I hope you enjoy the new functionality in a new version. All right. So what's next? There are cool information about from the community. So when we made a research about MicroStream, then we found a really cool investigation about MicroStream. It's called MicroStream versus JPA, an imperial investigation by the University of Bamberg. This is really awesome work, and the preprint is free for download, so you can check this out. We will put the link in the chat, and then you can check this out. So it's very interesting because these guys wanted to prove if what we are talking about MicroStream with microsecond query time, and it's 1000x faster than JPA. They want to prove this. They wanted to prove this and spend a lot of time on proving if this is really true, what we are saying. So this is very interesting. You should check this out. Yeah, very interesting. As I mentioned, we put the link in the chat and you can figure it out. Then, of course, new MicroStream joined the Eclipse Foundation. So we are very proud, and we are happy to announce that we are now a member of the Eclipse Foundation. We joined the Eclipse Foundation at the end of last year. And yeah, the reason is because MicroStream is already open source. And of course, we love open source. We use open source all the time, every single day. We are working on our own open source projects. And with the Eclipse Foundation, this becomes more powerful. We have the chance to work together with other awesome Eclipse members working on projects and combining the projects, combining MicroStream with other frameworks, getting in contact with the awesome developers from the Eclipse ecosystem to improve MicroStream more and more. And of course, the next step is MicroStream becomes an Eclipse project. So, and we are very excited to announce that MicroStream 8 will not be released. So thanks, Florian, for all these new features, but MicroStream 8, we won't launch MicroStream 8 because we will move the MicroStream project to the Eclipse Foundation, and then you get the features of the MicroStream version 8 as the very first Eclipse release. And we will split the MicroStream project into two single projects. So we will split it into MicroStream serialization and MicroStream persistence. So the names are not already defined, but in some weeks we will be able to announce the project names. And then we will continue MicroStream development under the roof of the Eclipse Foundation, under the umbrella of the Eclipse Foundation. So this is hopefully a great news for the community. So this gives us the chance to improve MicroStream more and more for the Java community. MicroStream and framework. So we have we do a lot of effort for integrating MicroStream with other frameworks. So MicroStream is already well integrated with Project Helidon, which is a very popular microservice framework. You know, the Helidon framework is the very first framework that's which provides actually two frameworks in one framework. So we have the Helidon SE and Helidon MP framework. We have great integrations for both flavors. And then, of course, we have a really beautiful integration with Micronaut. And as Florian mentioned, we work on various other integrations. And Rudy did a lot of research and put a lot of work in it. So Rudy, can you tell us a little bit more about the new integrations?
Yeah, sure. Let me share my screen, because I also have prepared a little demo and a little intro, so that you can understand the reasoning behind what we have done with those integrations. So first, a quick recap of how you are using MicroStream in a project, which are the most important aspects, and then how these functionalities, these features can be brought into those integrations. So yeah, you all know the storage manager, and when you start the storage manager, it reads the binary data from the storage. That can be a disk or a cloud storage, can be a database, whatever. And then that recreates your object graph. From the root on, it creates the entire tree, which you can use then, because they are simple POJOs. You can use them within your application. And whenever you change them with that store method, you use the store method of the storage manager, but actually it is the persistence manager underlying, which stores then your binary data again to the storage. That storage manager needs, of course, some kind of configuration. Most basic things is that it needs to know where that binary data is located. So that's one thing that you need to provide. But of course, you can configure a lot of things. We have defaults, but you can configure quite a lot of things within the storage manager. So that's what you typically use. You configure the storage manager, you start it, and then you use that store method. Of course, it has a lot more MicroStream. I see a few people from the attendee list, which I know that are using MicroStream, but on a very high level, that is the things that we try to make it easier, even although it is not that difficult to use the MicroStream functionality, to make it even more easier and integrated with various frameworks, various runtimes. So the configuration, we need to define the storage and other parameters. You need to define your root object, and you, in general, need access to that storage manager. So how can we integrate that within various frameworks, various runtimes, Spring Boot, Quarkus, Jakarta, etc. First of all, what I want to say is that you don't need to wait for us or the team until they create some kind of integration, because it is so simple to use. You can just configure it, define storage manager, and use it. So there is actually no integration required before you can use it. Of course, it can be sometimes a bit easier if you have an integration, but don't hold back on trying it out in whatever runtime, whatever environment you like, because it just works. That's one thing what I want to say, that don't wait for an integration. It's not because there is no integration that it does not work. Secondly, Markus told it already, we have integrations for Helidon and Micronaut. They are implemented with our help by those teams itself. So the Helidon team and the Micronaut team did it. So if you want to use them, you can just add the code artifacts from the vendor. For instance, you can add the Helidon MicroStream integration to your project if you are using Helidon, and then you have the capabilities of that integration. What I'm going to tell here in the rest of this little intro is mainly based on our integrations, what I'm going to tell next. but the functionality is more or less identical. They all provide that configuration capability of define the root object and access the storage manager. So that comes to the list of things that we provide as MicroStream itself. And in the release 7.1, you have already the Spring Boot 2 integration and the Jakarta EE8. So that's the Java X namespace, which is already there. So I hope that you could play with it already, that you have used it, and that you have seen what it's capable. Now in that upcoming release 8 or the Eclipse Foundation version, we will have the Spring Boot 3 version there. We have a Quarkus one for Quarkus 2, and we have the Jakarta E10 one, which is the Jakarta namespace-based version of Jakarta. They all have, all those integrations have the same functionality. There are sometimes small differences, but mainly they are just identical, even interface names and etc. are the same, so that it is easy if you, as a developer, need to switch from one runtime to another. For the configuration, we are using the externalized config options from every framework like Spring Boot or microprofile config for Quarkus and Jakarta, where we use the functionality of those runtimes to read the config files, the config from whatever is supported by that. That can be then file, that can be cloud, can be Git, whatever it is supported. The only thing that you need to remember is that we are looking for prefixed keys. So instead of just looking for the channel directory key or the directory location key or the channel count key, we are looking for prefixed keys because we don't want to clash with any kind of key that is used in Spring Boot or other frameworks or any kind of third-party library that you are using with your application. I'll show it to you in a moment. And secondly, what we also provide is that because all those runtimes have some kind of capabilities of injecting beans, like Spring Beans, CDI beans, that is that we provide the storage manager or the root object as injectable. That makes it, of course, very easy to access all those instances of all those functionality, all those features of MicroStream anywhere throughout your project code. So let us have a look now how you can use it. It's very minimal in the sense that we don't try to be invasive in your code. So you will see that it's just helping you for an easier config using best practices of your tool and faster access to those instances. For instance, this is the Spring Boot, the Spring Boot 3 example. If you like to play with it, on my GitHub account, I have created various repos which all ends with patterns. So I have created examples for Spring Boot, Helidon, Quarkus, and CDI, so Jakarta. They all do the same, so you can find that Spring Boot one, what I'm now showing in version 3, but you see version 2, there are all different kind of examples. Check them out, and there is some documentation here of what you can find in each of them, what is the reasoning behind it. So that should give you a start in how it works, why it works like this. It just here is standard Spring Boot project file where we add the dependency for MicroStream integration of Spring Boot 3. If you are using Spring Boot, then 2, then just remove the 3, and you have the older version for Spring Boot 2. This brings in all the required dependencies for MicroStream itself, so the storage manager, etc. So that's very easy to configure in your projects. I mentioned that we are reading configuration properties here. Yeah, just using this file like you have, that you have standard in it. But as I mentioned, you can use any kind of source which is supported by Spring Boot in this case. And don't forget to prefix because otherwise the integration does not find this storage directory because it looks for that one.microstream.key pattern. Here I define just a path to the location where the binary files are, and here, although not useful in this case because it is a very small example, but then you can see that also this channel count, for instance, is picked up. You see, it's simple examples, but it's more than just a hello world. So it is with quite a lot of classes already. So just want to make sure that you have already an idea how to use it actually in an application, because hello worlds are nice, but it's most of the time not very suited to show the real power or the real functionality. Our root object in this case, so the object at the top object of our object graph, which we normally provide to the connection foundation. Here we define it as a POSIO with a list of user and books, etc. But we specify in a notation which is similar to add component of Spring Boot, where we say, well, this is a singleton. So we create a singleton out of it, but we also provide it then as the root object for the storage manager. And because it turns into a CDI bean, you can also inject other beans. As you can see, we can inject the storage manager so that we can store a user when we add a user, etc. There is no constructor injector supported for the moment. We have a little bit of issues with that to get that working, but yeah, field injection, as you see with that auto-wired, that works fine. This storage manager is injected, so we also, not like this one. I need to click here. There you see we are in the configuration class of Spring. We define a bean which defines that storage manager. And you can see we have a primary here because, as I mentioned, as you have seen in the early access list, we provide, we have an update now in version 8 where you can have multiple support for multiple managers so that you have multiple databases. For instance, you can define a red database and you can define a green database, and then the configuration can be like this. And with the qualifier, you can inject the appropriate one that you need for that method, the one or one of the other databases. One of the examples is around that, so check out those GitHub repos. So we have here our root. As I mentioned, it becomes a singleton, which means that, for instance, we can inject it in a regular Spring bean as with using constructor injection, and we can return all the books, or we can do kind of full table scan with a where clause in that sense. But you can also make use of that new functionality of those collections, those segmented collections, etc. You can use indexes yourself. You can use Apache Lucene, whatever you like. So let's start up, because I have to just say one more thing. These keys are fine for most of the things, but some things are a little bit too tedious or difficult to do it all in configuration. So that's the reason why we have created this interface, and every bean, Spring Bean here in this case, which implement this interface, has the ability, opportunity to customize your storage foundation, and like you can register custom handlers, custom the specialized JDK8 type handlers or JDK17 one, which is a bit nicer to do it in code here. And we have something similar for the storage manager. A storage manager initializer interface. Whenever the storage manager is started, you have the opportunity to do some initialization, which can be nice to put some default data within a empty database. So when it first starts up, when there is nothing in your database yet, which then leaves us to the fact that if we have started, if I run the endpoint which is there, it returns those books that I have added here as an initialization. Here is my binary files. You see two channels as configured, so that works nice. Here in the startup, you see the logging. I especially added those kind of logging types things so that you can see that it is executed. Here also have a logging, so adding the basic data, adding the configuration, you see all those steps are performed as it should be. As I mentioned, very quick intro here for this webinar. Have a look at all the examples that I've created. I'm adding more and more examples and also more and more examples as we add more and more features. So we have the configuration, the declarative one through key value pairs from the config. We have that programmatic one. You can define one or more storage managers. So we have added the ability now to have more storage managers in one project, and we also have integrations with cache solutions like Spring Cache and the JCache for the Jakarta environments. This is not the end of all the framework integrations. We are already experimenting and planning the next integrations like Quarkus 3. There is that's in alpha for the moment. So whenever they go final, we create a integration specific for Quarkus 3. And we are playing around also with Kotlin so that you can have, for instance, improved integrations with the Kett web framework or the Hoplin configuration library that is used in those environments a lot. So not sure if there are questions specific about this one. Not for the moment I see, but if you do have questions, let us know now or later. And then I'll give the control back to Markus and Christian with another exciting news.
Thank you so much, Rudy. And thanks for a great presentation. So share my screen again. Yeah, MicroStream and frameworks. So for us, it's very important that MicroStream works beautiful together with other frameworks. So we have done a lot of additional work to make this happen, and yeah, work together with all the other framework vendors. And thanks to these teams supporting MicroStream, that's great. As you know, MicroStream also works together with Azul. So we had a talk with Gerrit Grunwald from Azul. We talked about the performance of MicroStream applications, and we know Azul is a great JVM, and it's fast. It should be faster than other JVMs, and which means, by the way, the faster your JVM is, the faster your MicroStream application will be. So which means it has a big effect on your application, which JVM you use, and as well as the Java version. So this is very interesting. So we played around with different Java versions, and we found out that so this is not surprising, but the later Java versions are much faster than the older Java versions. And now with Gerrit, we want to do a little research and benchmark, to show the differences between the Java versions and the different JVMs. This can be interesting for you guys to make a decision what JVM you use, because as I mentioned, the faster JVM is, the faster your MicroStream application will be. Hopefully we will do a MicroStream meetup about this performance test together with Gerrit. So I will invite him, and so if you guys are interested in this, join our one of the next meetups, hopefully together with Gerrit. From Azul, MicroStream clustering cloud. So now this is one of our most important topics we're working on for almost 2 years or even longer. So in terms of the time frame, I will skip my introduction into the problematic of running clusters. So I give directly to Christian, and he has prepared a demo about MicroStream cluster and cloud.
Thanks, Markus. So first I have to share the screen. Yes, here we are. Okay, so it's a great pleasure for me to do the first introduction of the MicroStream cloud. It felt that we worked 24/7 the last few months to get it started. So big thanks to all the developers of my team. That was really great. And let's talk a little bit about the cloud and why we need that cloud, or what was the idea of the cloud itself. So MicroStream cloud. So basically the basic idea was to provide an easy hosting platform for your MicroStream storages, so that MicroStream becomes more a database-like, I would say. And some of you might say, okay, MicroStream hosting as a storage, is it embedded, or why do we need a cloud or stuff like that? Many people ask us in the past how to share data with MicroStream to many different applications at the same time. And we answer all the time, okay, it's not a big deal, just take a Micronaut project and add MicroStream as a storage, and then provide REST endpoints to the consumers. And most of them, they understand this, and they ask at the same time, okay, I got this, but what about clustering and scaling and stuff like that? Does it work also? And then things becomes a little bit more difficult than at this time. And this is the point where the cloud makes sense for most of you guys. So it's a platform to easy hosting a MicroStream application, especially created with Micronaut or Helidon. No more security concerns because fully managed and stuff like that. We have backup services in the background and many, many, many more. Another point is, as I mentioned, is the possibility to provide a horizontal and vertical scaling of your data access. So that means we provide automatic scaling mechanisms or manual scaling, so you can scale up your cluster whenever you want. And as I said, load depending scaling of your nodes, of course. And that I would say, from my opinion, it's one of the biggest advantages to have a fully automated Kubernetes or container solution for everyone, fully managed Kubernetes builds, logging, monitoring, and many, many more, and to keep it as simple as possible. That is the basic idea of the cloud platform itself. So let's have a short look to the architecture. So let's see, okay, we have the part which is in front of the cluster. So I would say this is your responsible part. So we have multiple clients here, we have a load balancer, and these are some applications, servers, and this is the architecture you are responsible for. And in that example, we have some application nodes, load balancer clients, but these clients could also access the load balancer of our cluster directly. That's also so basically possible. So let's start with the cluster itself. So the first point of the cluster is our load balancer, and it's not only a load balancer, but let me explain that later a little bit. And behind that load balancer, we have our application nodes. That means every application or Micronode application you create will be clustered here behind that load balancer. And as you can see here, we have one write node and an infinite amount of read nodes. And whenever you write, whenever you send writing data, I would say, to the application, it will be replicated to all these read nodes here. And therefore, we need the load balancer again to decide which one is a write request and which one is a read request at the end. And this load balancer takes care about to separate the reads from the writes. And behind that nodes, there are many more stuff like the event stream, which is provided by a Kafka streaming, provided by Kafka. And there is also some storage stuff and backup stuff in the background, but this part is not that important. I think for now it's enough to just explain the architecture a little bit and how the idea works behind the scenes of the cluster itself. Okay, let's get into it. What are the things you have to do when you want to create a cloud or cluster project? So basically, first of all, you have to download a Micronode or Helidon cluster template project. We will provide these templates in the end, but you can also use any standardized Micronode project or Helidon from the launcher and add the necessary parts of the cluster itself, all the dependencies and all the classes. You can copy paste them, and you will be fine in the end. So we have the project. Then let's create the object model. So all the entities we need, or all the classes we need within the project. Then we need the REST endpoints and the controller classes, of course, to access this project. Then you have the possibility to add some Java business logic, of course, streams, filters, sortings, aggregation, stuff like that. And in some ways, it feels like to have stored procedures, so you can add your own business logic on the endpoint side to do aggregations and stuff like that. And in the next point, it's just a note, or it's just important to mention that you can use you will be able to start that project also on your local machine, for example, for testing purposes. But in the end, when you deploy the project to the cluster, it activates the cluster mode and it works within the cluster. That will work really great. Let's switch to the repository itself. So I created a small repo. Give me just a second to find it. Here we are. So let me just skip this. So can you see? So here we are. This is one example project in my GitHub account. So it's the cluster demo. And as I said, it's a Micronode project. And let's have a short look to the classes which are necessary to run. So let's start with the storage manager. Oh, let's go to the storage itself. Let's go to the DB class. Okay, this is the basic DB class. So let me just increase that a little bit. So we have the cluster storage manager. This is one of the important stuff. Normally we would use the embedded storage manager, but in this case we need the cluster storage manager because it contains additional business logic we need to make it happen within the cluster itself. So, but the code looks really the same that we have normally with an embedded storage. And all the other stuff, I would say, stays the same. So let's say, okay, we have domain classes here. There is only one product as a domain class. We have a name, description, price, stuff like that. And as you see, it's just the same. Let's go to the controller classes. Also, these controller methods are the same. We have some GET requests, we have some patches. It's quite standardized. There's nothing special in it. It's all handled by MicroStream cluster embedded storage. Okay, so that's the project. So we need this in the end to cluster it. And now let's switch back to the presentation, to the next part, and let's have a look to the front end part. So what has to be done on the cloud front end? So we have to choose the preferred cloud provider. That's important. At the beginning, we will provide access to AWS, but in the end, we are also working with Google Cloud and Azure. But it's not done at the moment. So the first start is on AWS. So then you will be able to choose the preferred cloud tier. So that means how strong the servers are, how many CPUs, how many RAM and stuff like that. And of course, also the amount of replications you need. So as you can see here, the smallest one is the replication 1. That means you have only one node, which is especially made for testing purposes or for development purposes. So it's just one node. It's like one small node, which is cheap. You can use it wherever you want, and then you can increase after that to small with 2 replications and 4 and go on. So we have the same on medium, but we will have a look in detail to that later. Then you have to choose the template provider. So there is a possibility to provide Git access. So then our cluster tries to access to your Git and take the project out of your Git repository, or you can also do a file upload. That's possible. Then you can adjust security and backup setting and stuff like that. Also routing and proxy settings, that's also important. As I mentioned, we have to find a solution to separate reads from the writes access. There are many different possibilities to do that, and you have to adjust this. And then you can start the cluster. And that's it. And based on that, let's jump into the cluster front end to show you how this is working. Okay, so the first time you access to the front end, you will see the welcome page and the dashboard. There are many different, many things you could do here. You can jump to your invoices, for example, or you can complete your account stuff, and you have the possibility to go to getting started and so on and so on. Many different. There is enough space to see the news at the end, but this is just a dashboard with also some helping stuff on it. A second page is the cluster page itself. So here is the part where your clusters are shown. So that means, as you can see here, there is still one cluster already in place with 4 replication. You can see that 4 nodes and 4 of them are running. This is the namespace and stuff like that. Let's have a look in detail later. Then we have profile section, so where you can see basic address and billing stuff, where you have your credit cards and you where all the billing stuff can be managed. You see some billing forecast and stuff like that. Yeah, that's not that important, I would say, but let's jump back to the cluster itself. So whenever you want to create a cluster, you can click on Add Cluster, and as I mentioned, you are able to choose Google Cloud or Azure or AWS, and also the different regions you want to host your cluster itself. I think this is really straightforward, nothing special. Then we can jump to the cluster tier. So, and this is what I mentioned, that we are able to say, okay, let's have a small cluster with one replica, for example, which has 1,000 millicores on CPU and 2 gigabytes of RAM, for example. And this is just a small, but you can also have a bigger one with 4 replicas, which has the same size of the nodes. So that means each node has 1 core and 2 gigabytes of RAM. Here you can choose the tier you want to have. And yeah, let's create a small one. That's enough. If you want, you could also enable the auto scaling function. That means it depends on the load you have on your cluster. You are able to switch the cluster size, or the cluster will be scale. For example, from small replica 1 to small or to medium or to small replica 4, for example. So that could be a case, a valid case. Then more replicas will start up and help to increase or help to keep the load or to handle the load. Okay, so in that case, we don't need this. Let's start a single one, a small one, or one. Then we have to provide a cluster name. Nothing special here. We have to choose the application type itself. We have to set the class path. This is a path you will get from your project. Then we need the information from our Git repository. So I already choose that. Yeah, for example. So this is the clone part. Let's jump back to the. So that is the repository URL, and then we have to add the branch, and that's it. We can keep it as it is. Let's say next. So now we can decide how many backups should be kept and in what interval the backup should be created. In that case, we have a minimum of 720 minutes. That is around every 6 hours, one backup of your storage. We have some cluster authentication stuff in place. And last but not least, we have the proxy settings, as I said. So here we can make the decision to separate reads from writes and how should this work. And in my opinion, I think that is the recommended way to do it. So let's say, okay, all the puts, posts, deletes, and patches should be forwarded to the writer node, and all the others can go to the read nodes. I would say this is really straightforward and also recommended. I already created a cluster like this, as I said. So let's jump back to this one. In the end, when we start the cluster, you should see a picture like that. So this is the cluster up and running. So as I said, we have one Kafka and Zookeeper in the background, which replicates the data to each node. And in this case, we have the 4 nodes here, and all these nodes are quite bored because they have no CPU usage. Nothing is going on that server. And yeah, you see all the different basic configuration stuff. You are all the time able to change the cluster size, for example, but let's do this later. We can do some backup configuration stuff, so that you can see here we have one backup kept. So every time when a new backup is created, the old one will be deleted. Here we have that backup. So let's here is that. Okay, so here is that backup. You are able to download and to upload those backups on storages and stuff like that. Nothing special. An important thing is to have all the monitoring stuff in place. You are able to monitor all your nodes at the end to see the workload of the CPU usage and the RAM usage of your nodes. You can also monitoring the Kafka stuff and or the proxy of your cluster to see, okay, does it work well? Is something going wrong or something like that? That's also important. And of course, it's more important to have the logs of your cluster. So every time you want to see the logs, you can choose the the nodes where you want to have those logs and see all the logging stuff in the end. I think that's quite helpful, especially when you try to find some errors or stuff like that. Okay, so that's it. Cluster is up and running. Let's try to stress the cluster a little bit. So I prepared a small JMeter application. So that means there is one thread group, and I say, okay, let's simulate 150 threads, which are firing all the time, around 40 times per second per thread. And let's see what happened and how the cluster can handle that amount of traffic. So I have my graph there, and yeah, let's start it. So let's jump to the graph. It looks really weird at the beginning, but the basic information is okay. At the moment, when it starts, we have a response time, which is around 68 milliseconds for each response. And when we jump to the amount of requests we are able to achieve. So at the moment we have 3,000 requests per second on the cluster. That's I would say that's okay. And let's check the cluster itself. So let's see what happened on the cluster side, and let's start the refresh. And we should see that the traffic is increasing. So does it refresh? Yeah, here we are. So let's activate the refresh here. And then now you can see the workload on the node machines are also increasing. So you will be able to see your workload at any time in the cluster, in the cloud front end. Let's jump back to the JMeter. Let's say, okay, 3,400 per second. Let's check the graph itself. Oh, we are on 71 milliseconds. Could be better. We already are working on some performance improvements, but I think most of the improvement could be Micronaut itself. So the Micronaut application isn't optimized at all. So that means there are many possibilities to improve that. So, but this is part for the next few days. And yeah, really great to see this is working. And I think yeah, I think it's okay to see the 3,500 per second. And I think completely we have 200,000 now requests and responses to the cluster. Yeah, really great, I would say. Oh, let's stop this. We no longer need that. And now you will see that the workload is going down, and yeah, really great. So that's all from my side. That's a small impression of the cloud front end. And so Markus, it's your part. Thank you.
Amazing, Christian. Thank you for the presentation. Awesome stuff. So we've worked on this for more than 2 years now, and hopefully we'll be able to launch it next week. So at least as beta version. And at this point, I like to say thank you for our entire team. It's not only the cluster team with Christian. So what you did is really awesome, and also thank you to the core team working on the core stuff every single day, improving the core features all the time. Now working on the Eclipse projects. really awesome. So fantastic. What's about the audience? So do you have any questions so far? No questions. So everything is common. MicroStream is fast. As always. Do you have any questions so far? So you have now the chance to ask the people who really write the code. So all of these guys are working on MicroStream all the time, every single day. No questions. So you can use the chat or your microphone. So the cool thing with this cluster and cloud solution is that by using REST, we are now able to let applications written in any programming language access to a MicroStream cluster. So many people ask the question, of course, they are not Java developers, obviously, is it possible to use the power of MicroStream in the MicroStream cluster with a .NET application, with .NET or Python? It was not possible so far because MicroStream is a Java library. You include it in your project and deploy it as a Java application. So no, it's possible with all JVM languages, but it's not possible with other programming languages. But now running MicroStream cluster it's possible really to let applications written in Python or .NET access to a MicroStream cluster. So this is also good news. If you guys like MicroStream, please start us on GitHub. So this is kind of like paying us. So it's open source. We do it for the Java community, and we're really proud on working open source. You can pay us by starting us on GitHub. And if you want to get started with MicroStream, we have a great documentation. We have the GitHub discussion where you can ask questions, and we will have a look on your questions, answer your questions. And of course, this webcast will be provided as a video soon. We have many videos already on YouTube. But as soon as we want, we will launch the first Eclipse version and cluster and cloud. We will produce lots of new videos and we'll provide it as videos on YouTube and also provide sessions. So yeah, check it out, play around, give us feedback, and we will also provide new MicroStream trainings. So we will announce these new trainings soon. Let's stay in contact, give us feedback. And now it's last chance for asking questions to Christian or Florian, Rudy. Yeah, Frank, thank you. Thanks for joining today. And yeah, check it out, MicroStream, and yeah, have a great evening or a great day in the US. Thank you for joining and goodbye. See you next time.